We have learned a lot about exponents. Let's take a moment to summarize what we've seen. We have now defined exponents x to the m for all rational numbers m, although our definition varied depending on what m is. In the beginning, if m was a positive integer, then x to the m means x times x times x times x, m times. And in general, for any numbers m and n, x to the m times x to the n is x to the m plus n. X to the m divided by x to the n is x to the m minus n. X to the negative m is 1 over x to the m. X to the m then raised to the n power is x to the m times n. X to the 1 over n means the nth root of x. And finally, x to the m over n, any rational number, means the nth root of x to the m power. Now, for rules 2 and 3, we're doing division by x, so we need to make sure that x is not 0. And for 5, we may need that x is bigger than or equal to 0 to take roots. For example, if n is 2, to take the square root, we need x to be bigger than or equal to 0. But if n were 3, then to take the cubed root, we have no restrictions on x. Now we use these rules to define exponents for more than just positive integers. Rule 2 allowed us to define x to the 0 to be 1. But remember, it comes from division, so we need to make sure that x is not 0. Rule 3 allows us to define exponents for negative integers, while Rule 5 allows us to define exponents for fractions of a special form, 1 over n. And finally, using 4 and 5 combined, we were able to define exponents for all fractions. It is fun to take a moment to notice that our understanding of exponents followed the same progression as our understanding of numbers in the beginning. First positive integers, then 0, then negative integers, then fractions that looked like 1 over n, and finally all fractions m over n.